And welcome back. Now it's a geometric series this video is on, and let's do it. Geometric series. Just to give you, I'm not going to show the formula. I'll show it in class, but basically I'll give you the formula. Now I'll show you where it comes from first, because it's really good. So let's say, let's just delete that comma, make it into a plus. And so let's say we've got our series. So remember, series is a sum. So 1 plus, we'll make the ratio 2 plus, so 4 plus, and we keep going, plus how high we'll go, multiplying by 2. So let's just do something simple. So it's 32 plus 64. There we go. And we'll stop there. How do we add all these numbers up together? So here we've got a common ratio. Again, Gauss figured out that to be able to add, to be able to do this, can you see how if we used Gauss's other trick to write 64, if we wrote 64 plus 32, these actually don't add up to what you want. That adds to 20, that adds up to 34. That does not work, okay? So Gauss came up with another trick, very clever. What he did is he multiplied everything by the ratio. Okay, so let's do this. Let's multiply this whole thing by 2. Let's see what happens. So 2 times Sn, which is going to multiply everything by 2. What's 1 times 2? Is 2. What's 2 times 2? 4. Might see what's happening. What's 4 times 2? 8. Plus dot 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 dot. Plus 32 times 2? 64. Plus 64 times 2? 128. And so he got this situation here. And what he saw from this is that he got these common things here, and that every term apart from the first term and the last term all matched up together, and from here you can simplify it really quickly. Okay, so what he did is he subtracted this series from this series. So he went 2Sn, so that's the bottom one, minus Sn. Okay, so that minus this. And so that means all these cancel out. 2 minus 2 is 0, 4 minus 4 is 0, 8 minus 8. So all of these that I've circled here just cancel out. And what do you get left with? The only thing you've got left is this 128 minus this 1 here. And that's all you have. And so that was a really clever way of being able to figure out what a geometric series is equal to. What's 2Sn minus Sn? You can think of this as 2x minus x. That's just Sn. That's just x. That's 2 lots of something minus 1 lot of something. You just get 1 lot of something is equal to 127. That's what that sum is equal to. And so that's where the formula for geometric series comes from. It uses that exact same thing. And what is the formula? The formula is, and you can prove this doing the exact same thing that I just did up here. And again, I'll show you in class. R to the n minus 1 over r minus 1. So that is your formula for the sum of any geometric series. Okay, perfect. Let's do an example or two. Okay, an example. Find the sum of the first 10 terms of this guy. 3, negative 9, 27, negative 81. Okay, find the sum of this. Let's write down, what do we know? A is equal to what? First term, 3. What's the ratio equal to? Well, what's everything being multiplied by? 3 times what is negative 9? You're multiplying by negative 3, multiplying by negative 3, multiplying by negative 3. So our ratio is negative 3. And in this case, we've got 10 terms, and so n is going to be equal to 10. So S10, our sum of first 10 terms, is going to be equal to A. I'll write down the formula again. A, because it's not on the same page, it'd be nice. Minus 1 equals 2. Whereas A is 3, in brackets r to the power n. So we're going to have negative 3 to the power of n, which is 10, minus 1. So get your negatives right, don't mess it up. r minus 1, negative 3 minus 1. Okay, pump that into your calculator. Might need to flip back a couple of times to do that. In fact, I should do it in calculator. Alright. Just going to forget what it was though, so I'm just going to, sorry for messing around a little bit here. So what have we got? We've got 3, so you can't see it when I do that, 3 bracket negative 3 to the 10. Yeah. 3 times bracket, I'll do another bracket, negative 3 to the power 10. And that should be minus 1. Minus 1. And that'll all be over. Oh, have I done it? Yes, it will allow me to do it. 3 times, that's negative 3, and negative 3 minus 1 is negative 4. Negative 4. And there's my sum there. So negative 44,286. Negative 44,286. Okay, beautiful. So if you sum all the terms together of this geometric series here, that's the answer you get there. So just use that formula. One more example I'll do of geometrics, and then we'll do something much more exciting. Example, how many years to save 5,000 if you invest 4,000, same numbers as we did before. If you invest $4,000 at 3% compounded annually. Okay. We're looking for N here. How many years to save up to $5,000? If you invest $4,000 in a bank that gives you 3% compounded annually, how many years? Let's write what we know. Initial, what's your first term? Is not 5,000. You're investing 4,000. Okay. And what else do we know? Our ratio. How much is it growing by every year? So, like I said before, it's 1.03. That's how much it's growing by every year. N, we don't know, but we do know that we want our... in fact, this is a bad question because it's asking for that term. So I'm just going to scrap this. I don't want to confuse people. I've just realised it's a bad question because this is not a sum question. This is actually a term question. So I'm just going to scrap this if that's okay with everyone. Thank you. See ya.